So our ultimate goal, just to give you a sense of where we're going to end up, at 1:55 next Tuesday, is that we're going to build a 5-stage pipeline. So we break the execution up into 5 distinct phases. The first phase is we fetch the instruction. So that's step 1, is to take the current PC and go off and get that instruction from main memory. So that first instruction fetch from main memory is in its own pipeline stage. The second thing we're going to do is we're going to decode that instruction, and for instructions that need operands from the register file, we're going to go fetch them from the register file. So step 2 of the operation is basically to get the necessary operands for step 3 of the execution of an instruction, which is to actually do whatever we're supposed to do with the 2 operands. Okay, so we've already on to step 3 here, and once we have the result from the AOU, for certainly the load and store instructions and the LDR instructions, we have to put in a step which is not needed by all instructions, but assuming that we use the same recipe to execute each instruction, we have to leave room in our recipe for loads and stores to go take the address computed by the AOU and to fetch the corresponding data, or to write new data into the location that was addressed by the result coming out of the AOU. And finally, when we're all done, for pretty much everybody but store, our job is to take whatever result we've ended up with through this up to now 4-stage pipeline, or 4-step process, and in the 5th stage, we write that information back in the register file. So this is the so-called classic 5-stage pipeline. So almost any book in computer architecture will basically, through various paths, explain to you how a 5-stage pipeline works. Now you look at, you scratch your head a little bit and say, okay, but I read just the other day that there's a 23-stage pipeline in my Intel processor. I mean, how does that work? And that's an interesting question, one that we're not going to talk about here.